In this video tutorial you will learn how to test communication and time synchronization in ED2 devices. Use the timestamps to get to a specific part of the video tutorial. IEDs of ED2 series have a diagnostic function that allows analyzing the statistics of data transmission via the device communication protocols. For the analysis of statistics in Smart Monitor, connect to the IED according to the video tutorial on operation of ED2 devices IED communication settings with PC. Next, proceed to the section Service menu. Network Diagnostics. The main section field shows the statistics on the selected type of communication protocol. Select Protocol from the drop-down list. If a specific protocol is not in the list, we recommend to check it in the section settings. Digital Communication Channels, Time Synchronization, or Communication Protocols tab. If the needed protocol is absent, it can be added. To learn how to do this, see other video tutorials on configuration of ED2 devices. Before start of IED protocols diagnostics, it is recommended to ensure that the connection between devices is physically correct. Also check the parameters of IED, the corresponding protocol must be enabled, its parameters set. Select 61850 Goose In from the drop-down list to check the reception of Goose messages. The open table shows the broadcast MAC address, incoming Goose messages ID and parameters of the counters. If Goose messages reception is correct, then the packets received counter value will increase, while value of 4 other devices, decoding errors, sequence number errors or time to live errors counters will stay the same. If these counters values change, then proceed as follows. If the 4 other devices counter changes, we recommend to check the correctness of such parameters as application identifier, Goose identifier and Goose configuration version. If the decoding errors counter changes, check the correctness of configuration of the incoming Goose data quantity and type. If time to live errors counter changes, it means that Goose messages are not coming or coming with long delay. Sequence number errors change means that by timestamps, Goose messages are out of sequence. In this cases, check the settings of incoming Goose for errors and test the data transmission in the Ethernet with a traffic analyzer, for example, Wireshark. If the value of the packets received counter does not change, then it is recommended to check the communication settings between IED and Goose Publisher, and make sure that incoming Goose are enabled in the parameters of IEC 61850 protocol. The value of test packets counter will increase when receiving test Goose messages. Maximum, minimum and average decode time of Goose messages are shown in the relevant counters. Select 61850 Goose Out from the drop-down list to check the sending of Goose messages by IED. The open table shows the broadcast MAC address, outgoing Goose messages application ID and values of the counters. If the packet's transmitted counters value increases, while transmitted errors does not change, this means that outgoing Goose messages are sent correctly. Transmission errors occur at forming of a Goose message, which size is bigger than the maximum size of the standard Ethernet packet. In this case, check the configuration of data type and quantity in the datasets of outgoing Goose messages for possible errors. If the value of the packet's transmitted counter does not change, we recommend to check the equipment network connection, verify that the permission for outgoing Goose messages is enabled in the parameters of protocol 61850-8-1 of the Digital Communication Channels section, and check the settings of outgoing Goose. If state number counters value changes, it means that signal values, quality and timestamp for SPS and DPS in the dataset of outgoing Goose have changed. Maximum, minimum and average sending time of Goose messages from the moment of adding it to queue for sending till the moment of its successful sending is displayed by the relevant counters. Note that during diagnostics of Goose messages transmission, on the IED display in the menu item Diagnostics. State of communication. In the 61850 Goose protocol section, the table will show the statistics of data transfer both at sending and receiving the messages. Select the relevant item from the drop-down list to check the data exchange via MMS protocol. The open table shows information on the network address of devices subscribed to IED's MMS reports. The values of MMS packets received and MMS packets transmitted increase when sending and answering MMS client's request respectively. If these counters' value is 0, this indicates that the communication between devices via this protocol is absent. In this case, it is recommended to check the presence of network connection. We also recommend to check the MMS client's subscription to the report control block. If the MMS client cannot subscribe to the report control block, mismatch of report control block quantity to client quantity may be among the possible reasons. To eliminate these reasons, set the required quantity of report control block copies and configure the client for subscription to the report control blocks. If the transmission and receipt of MMS reports is correct, the values of the MMS packets received and MMS packets transmitted counters will increase synchronously, while the values of the counters connect error, MMS packers decode error and error MMS packet sent must not change. If these counters change, then proceed as follows. If the connect error value changes, check the physical connection between devices. If the MMS packers decode error value changes, check the network settings of client for errors. If the error MMS packet sent value changes, check the IED's network settings for errors. The value of connect request counter changes upon the request for MMS packets reception. Upon successful connection of IED and equipment that sent the request, the connect answer counter value will also change. For diagnostics of report control blocks transmission via MMS protocol, select 61850 report control block from the drop-down list. The open table shows the name of reports that are sent to MMS client and the client IP address. Reports value increases at every MMS report sent, while events counter increases when the sent data values in reports change. Select the 61850 MMS client from the drop-down list to check the client part of the MMS protocol of the IEC 61850 standard. The open table shows the information on connected servers, server IP address, and quantity of subscribed reports that are sent to MMS client. The values of MMS requests and MMS responses counters will increase when changing of the report control block's data values. If the transmission and receipt of MMS reports is correct, the values of counters MMS requests and MMS responses increase synchronously, while the values of the counters connect error, disconnections and ignored PDU must not change. Below are the report control blocks names, their statuses, quantity of received reports and decoding errors. If the report subscription is correct, reports received counter value will increase every time at sending of MMS report, while decoding errors counter will be equal to 0. To learn how to configure MMS reports, incoming and outgoing Goose messages, watch the video tutorial on configuration of ED2 devices Goose, MMS protocols of the IEC 61850 standard. For sampled values protocol diagnostics, in Smart Monitor move to the section Current Values. Discrete Signals. Diagnostic Signals SV. This section represents the diagnostic signals for SV reception module and individual signals for every received stream. For more detailed information on these signals and SV streams configuring, check out the video tutorial on configuration of ED2 sampled values of IEC 61850 standard. Modbus RTU protocol diagnostics is conducted via IED display. For this, move to the menu item Diagnostics. State of communication. Use the buttons down and up to move between the lines. Use left or right arrows to move to the protocol. This protocol shows values of the counters of sent and received symbols and packets. If counter values are equal to 0, it means that the connection via RS485 interface to the IED and external device is not available. One of the possible reasons is that the used Modbus protocol IED address in this network is already taken. In this case, get back to the main menu and log in the Parameters menu item. Then to System Parameters. Communication Parameters. Serial ports, and set the IED address according to the project or change it to the vacant one in this network. The value has to be in the range from 1 to 254. For diagnostics of data transmission via Modbus TCP protocol, move to the relevant protocol. Here we can see the information on the quantity of used and vacant connections via this protocol, client IP address, time of the last received and sent packets, as well as values of the counters of received and sent symbols and packets. If the data transmission via this protocol is correct, the counters values should change. If these counters values are equal to 0, it means that the connection via Ethernet interface between the IED and external device is not available. Another reason is the inconsistency of IP address and subnet mask of devices that have to exchange data. Make sure that devices are in the same subnet. If according to the project the devices are located in the different subnets, make sure that the gateway address setting is correct. This parameter has to be the same for both devices. Watch the video tutorial on operation of ED2 devices IED communication settings with PC to know how to check these parameters. For diagnostics of devices polling via Modbus RTU and Modbus TCP protocols, switch to Modbus client. This window shows the information on connected devices, as well as the values of counters for sent and received symbols and packets. If counters for sent and received symbols and packets have the value equal to 0 or the sending errors and receipt errors counters change their value, then check the Modbus RTU/TCP protocol settings and the presence of the connection between devices via the corresponding interfaces. In this case, check the settings of communication between IED and external devices via RS485 or Ethernet interfaces. Know how to do it from the video tutorial on configuration of ED2 devices polling of IEDs via Modbus RTU/TCP protocols. For diagnostics of data transmission via IEC 60870-5-103, move to the relevant protocol. The statistics on data transmission, possible reasons for no connection, as well as ways of troubleshooting are similar to those described for the Modbus RTU diagnostics. Note that the IEC 103 Master Protocol Diagnostics is made only through IED display. For this, find the IEC 103 Master Protocol in the menu item Diagnostics. State of communication. Here the information on quantity of secondary devices and diagnostics on each secondary device is shown. Connection established. If there is no connection, check the parameters of the secondary device and the RS485 interface network parameters. Download a oscillogram for a specific secondary device. If there are no downloads, then the disturbance records downloading function is not configured. There are also counters for diagnostics of sending and receiving the data. If the counters of sending and receiving symbols and packets have the value 0 or the sending errors and receipt errors counters change their value, then it is necessary to verify the setting of communication between IED and external devices via RS485 interface. For diagnostics of data transmission over IEC 60870-5-104, move to the relevant protocol. It shows client IP address connected to the IED over this protocol, values of counters of sent and received packets, incorrect common address of ASDU, defining the format, contents and order of messages, and quantity of messages with not supported ASDU. If the data transmission over this protocol is correct, the values of packets received and packets sent counters will change. If these counters are not changing, it means that the connection via Ethernet interface between the IED and external device is not available. The fixing of this error was described earlier in the diagnostics of data transmission over Modbus TCP protocol. Incorrect common address of ASDU identifier is set as 1 if the ASDU general address over IEC 60870-5-104 protocol is set incorrectly. It is recommended to correct this address in the connected device or in the IED. Specify or change the ASDU general address in the settings of IEC 60870-5-104 protocol. ASDU not supported identifier is set as 1 when there is an unsupported ASDU in the received packet. The list of supported ASDU can be found in the ED2 series devices communication, time synchronization and network redundancy protocols manual, available for downloading from the tech support website. To know how to configure the data transmission and switching devices control via IEC 60870-5-104 protocol, watch the video tutorial on configuration of ED2 devices data sending and switching device control via IEC 60870-5-104 protocol. For diagnostics of PTP time synchronization protocol, move from the main menu to Diagnostics. Synchronization. The open table shows presence of IED synchronization. Configuration error of Ethernet redundancy board, in case of which it is necessary to contact the manufacturer. Last synchronization time. quantity of requests and repeated requests for synchronization with external device, and also the maximum quantity of repeated synchronization requests from the moment of sending a request to the moment of receiving the answer. If IED synchronizes over this protocol, the synchronizing via PTP parameter will have the value plus. If the parameter value is absent, it means that there is no time synchronization over PTP protocol. No communication with the time server can be the reason for this, so it is recommended to check the network connections of equipment. The same diagnostics information is available in the Smart Monitor software. For diagnostics of SNTP time synchronization protocol, proceed to the relevant item. The open table shows the information on the quantity of servers and the number of the active servers used for synchronization. There are also will be server IP address, quantity of sent and received packets, and also time characteristics. Time difference between IED and time server. Time for server to process the request. Client response timeout. One displayed in the summertime parameter means that the automatic transfer to summer or winter time is configured and the summertime is set at the moment. In other cases, the winter time will be set, the parameter value will be 0. Time of receiving of the last synchronization command. And last time received from server. If the server for SNTP protocol time synchronization is not displayed, then it is recommended to verify that the box of server enabling is checked, and that the parameters of server IP address and port are specified correctly in the configuration. PPS time synchronization diagnostics is made by the synchronization pulses service LED, which is on the IED front panel and blinks with a specific frequency. If this LED does not blink, and PPS synchronization error or absence is set to logic module in the state of modules on IED front panel and in Smart Monitor, then it is necessary to check if there are sync pulses, verify the polarity of the input PPS signal connection, as well as the conformity of the PPS synchronization parameters to the input sync pulse. IRIG-B time synchronization diagnostics is made as for PPS synchronization by the synchronization pulses service LED, which is on the IED front panel and blinks with a specific frequency. If this LED does not blink, see if the box for IRIG-B hardware synchronization enabling is checked, verify the polarity of the input signal connection, and the set parameters. Watch the video tutorial on configuration of ED2 devices time synchronization to know how to set the PPS and IRIG-B synchronization parameters. Next, it is possible to check the status of communication interfaces, for which the communication channel redundancy via link backup is made. When link backup is used in IEDs with one Ethernet 1 port, diagnostics is made only through the IED display, as it was described earlier. Ethernet 1 and Ethernet 2 interface ports will be used as redundant ports. By default, Ethernet 1 port is always set to LAN 1, while Ethernet 2 to LAN 2. One standing in the relevant parameter of the table means that this redundancy method is enabled. Names of the main and redundant interface ports are shown in the items LAN 1 and LAN 2 respectively. Presence of communication via one of the ports is also marked with 1 in the relevant parameter. Further in the table there is an interface number, which is used to connect to the IED at the moment, where 1 means the connection via the main interface LAN 1, 2, via the redundant interface LAN 2. When the active channel switches between the main and redundant interface ports, the counter value will increase. If the network redundancy over this channel uses ping requests, the relevant parameter will have the value 1. Also, the table shows IP address of the pulled device to which the ping requests are sent, counter of ping requests sent by IED, counter of ping request errors showing the quantity of non-answered ping requests, and the time of answer for the last ping request. In the IEDs with 2 Ethernet 1 ports, link backup redundancy operation is analyzed by 2 link and active LEDs of the Ethernet 1.1 and Ethernet 1.2 ports on the IED back panel. Link LEDs, indicating the fact of the physical connection with network over Ethernet cable, have to glow continuously. Active LEDs, indicating the data transmission via ports, have to blink. If link LEDs glow, while active LEDs do not blink, check the settings of IED or equipment network parameters for errors. Before the diagnostics of PRP redundancy protocol, make sure that the protocol is enabled. It can be checked in the Smart Monitor section settings, Digital Communication Channels, Reservation Settings, or through the IED menu section Parameters, System Parameters, Communication Parameters, Network Redundancy, Hardware Redundancy. Diagnostics of redundancy operation is made by two link and active LEDs of the Ethernet 1.1 and Ethernet 1.2 ports on the IED back panel, as it was said earlier. This video tutorial is over. We hope it was useful to you. Thank you for attention.